Mitochondria. So I'm taking H's from inside my mitochondria, and I'm putting them out here. Well, la te da, why do I want H's out there? So they'll come back in. Well, why would they want to come back in? Hey, right here. So I'm going to take H's out, so they'll come in and make ATP. Why would they want to come in?
Too crowded.
Too crowded out there. Very good. I pump them out so they'll re-enter. And why do they want to re-enter? By diffusion. Damn it! All right. There's more H's outside than inside. So diffusion says more to less. They want to come in. Another view of this. Another view. Simple view. So I'm taking H's out. You can tell I got excited, right? I take H's out, outside, and they zip in. Gradient means diffusion. They zip back in the cell. And why are they zipping back? Because of diffusion. Why do we want them to zip in? To make ATP. So essentially, have you heard the water wheel effect? So when the H's zip through this tube, it actually spins this protein, and it's actually called the lollipop. Mitchell chemismatic lollipop. But it actually spins this, and you can use that to make ATP. So the goal of the diffusion is to make energy. Another view, back to the more formal view. I pump them out, so they'll zip in, and see this spins? That's actually true. I make ATP. First one go to ATP? Okay, but what does it take to do that? I have the H's. There's something else I need besides H's. What is it? I know I ate ADP. There's something else. Oxygen. I need to add oxygen to this process. And what does oxygen make? Water. So for the last step to work, I have to use oxygen to make water for me to do my spin the lollipop. Sounds so corny. Probably made it up. Mitchell actually got a Nobel Prize for making up that. Okay? So do an ETC. So let's put this whole thing together in its own gruesome way. Here we go. Here's our steps. Glycolysis. Glucose to 2-pyruvate. How much energy do I make? 4 total, but how much do I actually earn from this? 2. Bad investment, I get 2. Okay. I'm going to make acetyl-CoA, the intermediary. That goes to my Krebs cycle. How much energy do I make in my Krebs cycle? 2. And I make all this other crud. What's all the other crud for? To go to ETC. What does it do in ETC? Makes ATP. How much ATP? A whole lot more. So how much do you make total? 30 something. The numbers vary depending on who you talk to. So which step is the most important step? Electron transport chain. This guy. So essentially the other 2 steps are just to get you to number 3. Because that's where we're going to make the ATP by using oxygen and the letters. So what do we call it if you're using oxygen to make energy? Aerobic. So when you're doing aerobic metabolism, you're doing step 3. I'm using oxygen to make energy. Sorry?
So glycolysis and the acetyl-CoA is anaerobic?
Glycolysis is considered anaerobic. Krebs cycle is sort of one that don't actually label, because it does a couple different things. Is that okay? Okay, get out your packet of pain. We're going to flesh this out some. Find your packet of doom.
Am I right?
Find the metabolism case study. It's a couple after the one we did on choline, which we'll come back to later. Metabolism case study.
That was a whole lot of people in the past.
Okay, we're going to do this one sort of as a class. Help get your brains moving here. Where to find it? Okay, we got this little girl, well, 15, okay. Shortest breath clamps after walking a block. Does that sound good? No. Low tolerance, gets worse. Okay, muscle wasting. Treadmill goes to 80 to 160 in 3 minutes, not good. And then the magic number, serum lactate levels increase 4 times. So question 1, what is serum lactate? Where is serum lactate? Lactic acid where? In your plasma, in your blood. Serum, blood, lactate. Okay, I don't see lactate anywhere on the drawing they gave you today. So tell me what lactate means.
You should not be very deep.
That's right. Let's take a look here. There's another pathway. We can go glucose through glycolysis to pyruvate to lactic acid only. So we only do step 1. When do we only do step 1? You're anaerobic. So if you're anaerobic, only glycolysis. Okay, what does anaerobic mean again?
No oxygen.
No oxygen. So let's figure that out. Why would no oxygen make you only do glycolysis? So let's go back over here. Number 3, what happens if I don't have oxygen in step 3? I can't do ETC, right? Okay, so why can't I do Krebs if I don't have ETC?
CO2?
Got the CO2. Close though. Let's go back over here. What's the job of Krebs cycle? What's it supposed to make? Feed, right? Okay, and what's making those for ETC. So if ETC isn't using them, what's Krebs cycle going to do if you're not using what I'm making yet? I'm going to stop making it. Because why should I spend all the time and money if you're not going to care? So what happens to Krebs cycle when you turn off ETC? It stops. So what are you left with? Only glycolysis. But the problem is, if I'm an anaerobic, I do glycolysis to pyruvate, and I make that guy. So I make lactic acid, or lactate. So if her serum lactate levels are climbing, she is anaerobic. She is no longer doing steps 2 and 3. Does that make sense? Tyler, do you have a question?
Oh, no, you answered.
Okay. So okay on the serum lactate thing? So now let's do the second paragraph. Or the second one. Okay, they did all this fancy, expensive stuff, and they found out she has no cytochrome B. Fantastic. What is cytochrome B? Where is cytochrome B?
Isn't that one of those big old blobs in the ETC?
Very good. Here's cytochrome B. Cytochrome B are the big blobs in the ETC. So when we do the ETC, this is with cytochromes. Cytochromes are the chemicals that do the 3rd step. So if she's missing cytochromes, can she do ETC? No, she cannot. Because there's nothing to pump the hydrogens out to make the water wheel go.
That's what cytochromes do.
That's what cytochromes do. They're the enzymes that do the ETC. Or you can argue the enzymes for aerobic. So let's go down to question 3. What's the function of cytochromes?
Pump out the hydrogen.
To pump out hydrogen, perform ETC, do aerobic respiration, however you want to phrase that. Their job is to pump the H's. So if they were absent, you would stop doing what? Stop making energy, stop ETC.
Which stops Krebs.
Yeah, which stops Krebs, which makes your life miserable. So let's go up to question